Good afternoon, everyone. So my name's Jill Cooper. I'm the head of department here at WQE in the Maths department. So what my plan for this taster session is about 20 minutes of looking at some A-level maths things that we're going to be doing. And then sort of the last 10 minutes, I'll do a little bit of a explanation about A-level maths at WQE. So I'll do it at the end rather than at the beginning. So we'll go into presentation. So at the end, I'll do a bit about WQE, and you can ask some sort of time for some questions as well at that point. Okay. So let me share this screen. So this is something from a website, which I will give you the link to, or admissions will send out the link to you afterwards, because there's other things on there that you might want to have a play with. All right, so a little bit of a video to start with. This is looking at sequences and series, something you've come across at GCSE and something we go into a little bit more detail at A-level. So it's a 4-minute video first, and then we'll go through some questions and get you involved and engaged as well. So if you have got a pencil, pen, calculator with you, that would be great. We're not going to get through all of it, but so you can then go and have a play yourself and go through things. So it's to do with infinite sequences and series. So I'm just going to expand it, and we'll play first about 4 minutes.
Desmos task: provide an introduction to the mathematical topic of infinite series. This is studied by anyone who takes A-level mathematics and is usually covered in the second half of the course. One of the great things about mathematics is that ideas that might seem abstract often have significant applications. Consider, for example, the function y equals sine x. The first person to draw this graph probably did so because they were interested in the mathematics. But subsequently, sine waves have been used to model anything that has a periodic nature, such as the movement of tides and ultrasound scans. Think also of the vast amount of data that is sent using electromagnetic waves, and you can begin to see that actually the sine curve underpins so much of modern technology. Every piece of mathematics that you study at A-level will have many and varied applications. However, for many people, the joy of mathematics is being able to explore ideas that are seemingly abstract. Take the concept of infinity. Most people would probably be quite happy with this statement, that 1/3 is equal to 0.33333 recurring for infinity. However, if we multiply through by 3, we get a statement that some people find quite unsettling. Can 1 really be the same as 0.9 recurring? When you start to look in depth at infinity, which is something you will do a lot at A-level, you do often get some surprising results. Let's look at another example. Here I have a frog who can jump 1 metre in length. However, in making this jump, the frog becomes tired, so its next jump is limited to only 1/2 metre. Each subsequent jump is halved in length. What is the total distance that the frog can jump from its starting point? You will probably be able to see that the frog is going to get closer and closer and closer to 2 metres. But does it ever actually get there? The gap between the frog and the 2 metre mark will continue to reduce over time with each jump. If that gap becomes infinitely small, can we say that it doesn't exist at all? You will have the chance to explore this problem further in the accompanying Desmos activity. For now, I will leave you with another surprising result. Imagine having a shape that begins with a square measuring 1 metre by 1 metre. To that square I add another square with a side length of 1/2 metre, and then another square with a side length of 1/3 of a metre, and then 1/4 of a metre, and so on, infinitely adding increasingly smaller squares. What would be the area of the resulting shape? What would be its perimeter? You might like to pause the video at this point and think about that question before I go any further. The result of this question might be surprising. As we can see, the shape is growing infinitely, and its total perimeter will also continue to grow infinitely without limit. However, despite the fact that it continues to grow and grow and grow, its area never gets bigger than 2 square meters. In other words, here we have a shape that has a finite area but an infinite perimeter. How can that be possible? By working through the accompanying Desmos activity, you will learn some A-level mathematics that will enable us to prove this surprising result.
Okay, folks, so that was just a little bit of a PowerPoint video sort of introducing sequences, an infinite sequences and series. The first one is the more, move that out of the way, more sort of useful question that we're going to have a look at rather than the second one. That's a bit more challenging. There is information on this you can sort of prove that as well, but let's have a look. And all we're going to have time to look at is the first type of series. Okay, so you will have come across sequences at your GCSE. Okay, and basically a series is just where we take a sequence and add the numbers together, as you can see some below. So we've got some examples of types of series. We've got a periodic one, it goes 2 3 2 3 2 3, and it might be relatively easy to hopefully add up this. You know, the idea with the series is that we want to add these up. A lot of the contexts for this, like that jump from the frog, if I add up how far the frog has gone in total, where are they going to get to? So lots of context questions involving sequences and series and actually adding them up. Okay, arithmetic series, the second example here, you will have seen these types at GCSE where you're sort of adding or subtracting the same number each time. And at GCSE, you've been asked to, you know, find the nth term of the sequence, haven't you? Okay, that is a special one that we will also look at, is arithmetic series. Okay, so that is within the A-level specification. You've hopefully come across the last one, Fibonacci's, where you sort of add the previous two terms together to get the next one. And we do have a way of maths of writing that. We call them recurrence relations, and that is something else that you will look at in your A-level maths if that's what you decide you want to go and do. It's part of the specification. Okay, the one that they were talking about in terms of the frog going 1 and then a half and then a quarter, that's what we call a geometric series, and that's what we're just going to have a little bit of a look at and introduce you to. Okay, so geometric series, to get the next term, what we need to do, basically the key thing is to multiply, it's this bit here, the previous term by this some fixed amount. It's got to be the same number each time. Okay, that's the key definition. So if we look at their example, and we call that the common ratio because it's your ratio of your terms. So the second divided by the first term is 3. The third divided by the second, it's 3. Okay, so the common ratio is the thing that you're timesing by. And as you can see, what we've also defined is the first term. Because if I know what the first term is and what the common ratio is, I can work out the terms of the series. Okay, does that make sense? So what we've got on the right here, we've got 1, 2, 3, 4, 5 series, because they're sort of added, we've got some subtractions in there, but they're added together. Okay, so the question is, which of these, there's more than one. So if we call the first one 1, 2, 3, 4, 5, in the question and answer box, do you want to just write, you know, if you think 1 and 2, I'll just put 1, 2. If you think 4 and 5, I'll put 4, 5. Do you want to just have a put what you think the these are geometric? So let's have a quick look. So we've got 1, 2, 4, 1, 2, 1, 2, 4. We've got a 5 in there. The common 1, 2, 4, 1, 2, 4. Okay, they seem to be the common ones across. So we'll put a tick in 1, 2, and 4. And let's have a check then, folks. I think you're right from what I can think. Well done. Yeah. So what you've got as well, well done, folks who didn't be put off by the minus. Times in by -2 for the first one, aren't we, each time? That's fine. Second one, you think, oh, well, we're dividing this, aren't we? Well, we are in a sense, but we always talk about multiplying we're multiplying by a half. Okay, so spot on for that one. Yeah, the next one is we're just adding one, aren't we? And then again, we're timesing by 1/10 or 0.1. And the last one, what we had in 10, it doesn't work, does it? I don't think on there. So well done, those who've got 1, 2, and 4. Spot on, well done. Yeah, loads of you. Yeah, so spot on there. The sign doesn't matter. As long as the sign's got to matter because it's got to go plus minus in a sense. So if you're timesing by a negative, it will be plus minus like the first one. Okay. So you'll never get a geometric series which is all minuses. Okay. Excellent. Well done. So let's have a look at the next. So there's some, obviously you can go through this later as well yourself. It's obviously giving you some information, but that's what we've gone through. Now then, so a bit more multiple choice, folks. So we'll look at this one. So can you work out, we're told it's a geometric series, could you work out what the 5th term is going to be? So it must be one of these. Well, it says none of the above, so maybe it might not be. I think it is from, do you want to have a quick go? So you might need a calculator. I'll give you a little bit of time to have a go. We've got a couple of answers coming through. Okay. So we've got a mixture of answers so far. We've got an 81 and a 54 so far. 81, 81. A lot more 81s. Oh, another 50. So let's have a little look and then let's decide. So hopefully job number 1, I need to work out that common ratio. Yeah, so if you get a question right, what is that? What am I timesing by each time? So the easiest way, if you're not so sure, do the second term divided by the first term. And I think, is that 1.5? Is that what folks got? We need to times by 1.5 each time. Is that right? Should work the same. Yeah. So what I need to do is 36. If I times it by 1.5, isn't that the 54? So calculate 36 times 1.5. That's the 54. So some of you put the 54. That's the 4th term. Okay. So we need to do it again to get the 5th term, which does give us 81, I think. Yeah, we're happy with that. So those of you with 54, I think you just, that's it. We've got some times in by 1.5. Oh, 96. Yeah. So does that seem 81? We've got, yeah, times in by 1.5. So 36 times 1.5, 54 is the 4th. Times it by 1.5 again. I've got 81 is the 5th. So we'll double check that one in a minute. How about this one? Bit more problem solving. And this is what you get sort of in A-level maths. Okay, right. The first one, here's the series, find the 5th. They're the nicer questions. But what about this one? A little bit more complicated. We've got the 4th term is 14 and the 5th is -7. And this time it wants us to find the 1st term. Okay, we've got a couple of answers. Some of you are very quick, which is brilliant. Well done. You're obviously looking ahead as well. Yeah, so we've got some excellent answers. I can see some, what I believe, some correct answers. I'll give obviously people a few more. So somebody's got a slightly different answer. We'll have a look there as well. Any more? So say a lot of you are going with -112, which I think is the right answer. Let's just have a little bit of a chat through why that might be the case, because there's one or two some slightly different ones as well, and we'll see what. But so this is the more sort of challenging type problem solving question. So job number 1 as well. If I've got the 4th and the 5th, what is the common ratio? What do I need to times the 4th by to get to the 5th? So if you're not so sure, you can do the -7 divided by 14. Does that -1/2? Do I have to times 14 by -1/2? Would that work to get -7? So I can't, unfortunately, I can't draw on this web page, unfortunately, which is a bit of a shame. But normally I'd get my graphics tablet and try writing on it, which I did in classes and things. So, but to go from the 14 to the, I'm going to sort of use my cursor, if you can see that on the screen. To go that way, I'm going to times, it goes as well, by -1/2. So if I want to find the third term, I need to sort of go the other way. So instead of timesing by -1/2, I'm going to have to do the opposite. I'm going to have to divide by -1/2. Yeah, so if I divide the 14 by -1/2, I think that gets me -28. Is that right? That must have been the third term. I need to divide by -1/2 again, which is going to get me to the second term. So what's that going to be? -54, plus 54, beg your pardon. That will get me to the second. And then if I do it again, I think that gets me to -112. Does that make sense to folks? I think a lot of you've got that. Yeah, dividing by, excellent, spot on. I will, Sanchez said about the code, I will get admissions to send you the link to this website at the end of today, so you can go on and have a play yourself. And there's some other activities on there as well that you might want to have a go at. And they're a useful website for, you know, people interested in maths and doing maths further. So, you know, have a look at that. Okay, so let's check our answers. Spot on. Okay, so what we've got a couple of minutes, because obviously I want to give you time for some questions. Okay, so we'll just do this one. And then we'll say, well, chance obviously I'll give some information about maths at WQE, and then obviously chance for some questions, because I think there was a question earlier that came on as well. So the reason for having now a series instead of a sequence is to add these things up. Okay, so adding up the numbers gives an answer to a particular problem. Okay, so you've got a little bit of notation here, and obviously maths notation is important. This S with this subscript n is the sum, S for sum, of the first n terms of the series. So here we've got a series, it's a geometric series. So the sum, it says, of the first 3 terms are 2 plus 6 plus 18, 26. So we would say S of 3 equals 26. Yeah, so we're adding up those terms. So what do you think the sum of the first 6 terms is going to be? I think let's see what you can do. Let's see what answers anybody have got. 728. 728. Oh, got a slightly different. We'll come and have a look at that. So 728 seems to be the common answer. Excellent. So let's put that in 728 and we'll check. Well done. Yeah. So hopefully we've got 1, 2, 3, 4, 5 terms. So I need the 6th. So it's spotting again. Key thing, what's the common ratio? I think we're spotting it times it by 3. So I'm going to need 162 times it by 3, gets me the 6th term. And then if I go add up all the numbers, I think I've missed one at 54. That's it. We get 728. Okay. Now then, hopefully you can see, right, if I've got 20 numbers, how, you know, I don't want to have to do that one plus that one plus that one. There is a formula that we use, and the next slide is going to sort of go through that, start looking at doing the sums of how we can get the formulas and things. So there is a formula, because obviously you say if you've got a lot, we don't want to do that. Okay, but I say we're out of time for me, because I thought if I go to past, and then it'll give you sort of time to ask some questions and things. But I say you can certainly, you know, carry this on yourself. On here, let me just take you to this. This is the Advanced Math Support Program. It's got stuff for students, lots of stuff. It's got stuff for obviously teachers as well. Okay. Oops, gone the wrong way. And what you've got is various different links. Let me go back again. Will it go back again? Yeah, this is what I was after. So I'm having a look at the infinite series things with you. That's what I've done. There is another one for A-level maths here that you want to have a look at, and there are some for further maths. If some of you doing further maths later, Mr. Orchard is going to do the complex numbers. He's going to introduce you to how do we square root negatives. Okay, so he'll have a look at that. That's at 1:30, isn't it? If those of you who are thinking of having a look at the further maths thing. Okay, so I will pause the share screen there and I'll go to some questions and things. So I'll have that up. Okay, so I can see some questions coming through and I'll try my best to sort of answer. So average class size, well, maximum is 24 in all the subjects, okay, but it could be slightly smaller than that. We'll wait and see how many students enroll. So exam board, we use Pearson EdXL. All the exam boards, the content is the same across all the exam boards, okay. But so we use Pearson EdXL. I mean, that seems to be sort of the common question that's sort of coming through. Somebody's put sort of AQA, so Pearson, that's the exam board. So textbooks we use the Pearson textbooks. Okay, what we give you access to is the online textbook. Somebody's asked about buying the textbooks. You can buy the textbooks, all right, for the A-level maths if you wish to. So we use the Pearson, you've got online access to it. But yes, if you want a hard copy, by all means, you could buy your own as well. Okay, so it is useful. The online textbook does have work solutions, so it's useful to have that even if you've got the hard copy, because it's got all the lines of the work solutions. All right, topics of A-level maths starts from GCSE and adds to it. So as you can see, their sequences and series is what we've had. Calculus. If anybody come across calculus? Come across that at all? So that's a big part of maths where we call differentiating and integrating. Okay, and so it uses lots of skills in terms of your algebra. It has lots of applications. Does calculus. We introduce you to more trigonometry, more coordinate geometry, lots more sort of trig functions that are out there as well. You know, lots more bits and pieces that you think, you know, maths can go on for forever. Okay, with that. So how many hours a week do we have of maths? Well, I'm hoping we've got normal lessons and things next time. So all your A levels are 4 lots of an hour and 10 minutes. Okay. We've got exam board questions coming through. I thought I'd answered that already. Pearson EdXL is your exam board. Okay, so I've answered that one. Do you get a choice of stats or mechanics? You don't anymore. No. So all the exam boards it's exactly the same specification, exactly the same content. You have to do some stats and some mechanics. So 2/3 of it is pure maths, 1/6 stats and 1/6 mechanics. Okay. Calculators, another key question. Good. Someone's asked about a calculator. So you will need a calculator that is probably different from your GCSE one. Okay, you need to have access to the statistics. Okay, so there's a silvery white, what we call ClassWiz calculator, or you can go for a graphic calculator if you wish to. It doesn't matter. Okay, so what we will do is in the first lesson that you have with us, we will show you the calculators. Okay, so that you can do. Don't buy anything yet. I would say wait until you come in September. We'll show you the calculators, and then of course obviously it's, you know, it's what you can afford as well, isn't it? So you will need to potentially upgrade if you haven't got I know there's a new ClassWiz, a little sort of calculator, but it's only got a few menus. There's another version for A-level maths, which is about just over £20 is that one. Okay, so you will, but also we will show you them, we'll give you advice, and obviously it is expensive, it can be expensive, so bursaries are available if finances are an issue, because obviously you will need to use it to do A-level maths. Okay, so let me have a what's the most advanced topic in A-level maths has been asked. I don't know, advanced, I suppose calculus. I mean, calculus goes on, there's lots and lots of things with calculus that you can do, areas under curves, finding maximums and minimums and optimizing. So probably is an advanced topic, as well as lots of trigonometry. different trig functions and solving trig equations and all sorts of other bits and pieces. So there's a lot of advanced topics in there. Let me just scroll. Revision guides. Yeah, I mean, Pearson do a revision guide that goes with the course as well, but sometimes I think it's what you like the look of. So if you sort of look online and have a look, they usually have a look at a couple of pages for you within that, and it's practice as well. So it's finding what you would prefer. But I say the key to maths, there's a couple of further maths questions. I'll sort that in a second. The key to maths is practice, folks. Okay. What it's one thing knowing, it's like a formula. I know the formula, right? The next thing is, how do I know when to use it, how to use it? Maths is a practice sport. That's what I call it. People are into sport and things. How do you get better? We've seen the European Cup, aren't we, at the minute? The skill that these people are showing, they practice day in, day out on the pitch, so it becomes natural. That's what you guys have got to do as well. You do the stuff in the lessons, teachers set your homework and things. You've got to practice as well. That is the key thing. And we obviously give you lots of resources to do that. We've got the textbooks. We've got online, our WQE online things as well. Absolutely, yeah. Somebody's asked about past papers. Yeah, we'll provide you with lots of practice papers and past papers, because that's the key thing. Is topic is one thing, right? Exam technique is another, and we will help you with that. Okay. Best websites to practice A-level maths. There's things like Maths Genie. Okay, things like exam solutions, because they've got videos as well and practice questions. Okay, so when you join us, we give you an information booklet at the start of the year with the course content, okay, how to revise, all right, as well, what you can do the practicing, and links to websites that you can go on and practice yourself. Okay, but I say Maths Genie and exam solutions, the two that are useful off the top of my head. There are others, but yeah, you can watch videos, you can practice questions. Is some of the content and the question structure similar to the OCR freestanding maths? Some of the content, I think if you've done some calculus, I think, isn't there potentially in that? I know the further GCSE has some calculus and things in there. So it could have similar things. If you've done that, your starting of the course hopefully will be familiar to you. Okay, we've got a workload question compared to GCSEs. Yes, I mean, in a sense, you're going to be studying potentially 3 subjects instead of however many, 8 or 9, and you're going to have time. You're not going to be in lessons all the time, but you've got to manage that time. Doesn't mean you're free, so there is a workload. You've got to keep practicing things. Okay, but I say you will have, you'll find you have some free time within the day to do that extra practice. And as I say, it's coming back to that. So I would say, yes, there is an increase in workload, but you're doing hopefully three subjects that you'll want to do and are good at. Okay. I've been told just about time's up, folks, so I'm going to have to sort of wrap it up there. But I will make sure that we send, these slides get sent to you so you can have a practice. And obviously, if you have any other questions, ask the admissions and they'll email them on to me and I can reply to you. So thank you very much for joining me this afternoon. There is a further maths one at 1:30, I think it is, if anybody else is interested. Thank you very much.